Hi, my name is Ross Haxton. This presentation will discuss UAVs, or Unmanned Aerial Vehicles, and some of the applications in mining. UAVs can be mobilized quickly and are easily transportable on conventional aircraft. Results are provided fast and at a fraction of the cost of a manned aircraft. The process for capturing data using a UAV involves firstly interrogating the area of interest and determining a flight plan. This flight plan is subject to many things, including the accuracy required, the wind direction and strength, along with the terrain involved. Photography is captured via the UAV, and photogrammetric methods are used to gain the results. Wind gusting up to 60 kilometers an hour has been encountered during flights with this UAV. The plane is launched from the hand and cruises up to the determined height to gather information to satisfy the ground sampling distance for the area of interest. The plane then follows the flight plan, taking photos at nominated distances to achieve the overlap required for forward, rear, and side photography. The accuracy of this UAV platform is 2 to 5 centimeters and uses no ground control points. The control points are captured using RTK, or real-time kinematic survey-accurate GPS, on board the plane. This enables the user to select the accuracy required and the ground sampling distance. The data captured from the flight is then processed using high-end computers. Each camera location is recorded and the associated photo is matched to this position. These photos are then processed to produce the final products. These products include a processed orthophoto of the area of interest, which is stitched together and orthorectified. Orthorectified means the aerial image has been geometrically corrected so that the scale is uniform across the photo. Along with this processed orthophoto, we get a processed DEM, or digital elevation model, of the data. The ground sampling distances for this DEM are determined during the flight plan and result in XYZ points created based on these specifications, usually around 3 centimeters apart for each point. From this processed data of the DEM and the orthophoto, we can get additional products for use within a mine site application. Some of the examples of additional products that we have created from this DEM are catchment watersheds and slope analysis. So to demonstrate this image displays a flight as a regulation DEM with the different contour levels in different colors. From this DEM, we can create catchments, streams, and pour points. Pour points are simply where a stream exits a catchment, an individual catchment. As an example of the use of this information in this case, we can zoom into this area here. And we have an area where flood mitigation could be applied to this pit. In this area, we could create a bund across this edge of the pit here. This would stop the stream running into the pit and therefore helping in a flood situation, water being diverted back the other direction. This is all done just from analysis of a DEM. Another example of the use of this DEM would be to analyze the ramps. this area here, we can see a section of the ramp which through slope analysis we can see is greater than the required grade. So this area here in red is highlighted because it is greater than the grade acceptable for truck haulage. Having the DEM as well as the ortho-rectified image, we can create some visualization tools. Examples like movies or interactive models. In this example, we are showing an area of a pit where there's been a large slump. And to monitor the slump would require to put people into harm's way to get this sort of imagery. You can see what sort of detail we can get as we zoom into this model, all in areas where people just cannot access. As we pan across the model, this visualization highlights a recent area of slumping of up to 10 meters. And with good visualization, we can get a good idea of the extent and the areas affected, as the model is spatially correct. Therefore, we can interrogate it and measure off it as well. This model was created from a 25-minute flight, which took about 1,000 photos and was processed overnight, and the results supplied the next day. I hope this presentation has been of interest to you. This presentation is simply a taste of what can be achieved from a UAV platform. Alternate platforms provide additional advantages, and many applications simply just haven't been thought of yet.